So, a presentation on understanding software bill of materials or enhancing software security and transparency. First, we'll go into the definition of the sbom or software bomb. It's a detailed list of that outlines the various components that make up the software application. These components can include open source libraries, third-party modules, and proprietary code. By documenting these elements, an sbom helps developers, security teams, and other stakeholders understand what the software consists of and manage it more effectively. The key components of an sbom: the component name, and the version, specific version of the component used in the software supplier, about information about supplier or the author of the component, licensing details of the licensing terms and conditions of each component, dependency information about the other components or libraries that each component relies on, and then there's a unique identifier or a checksum or hash that ensures the integrity of the component. Benefits of sbom: transparency and accountability, improved vulnerability management, compliance and regulation adherence, efficient software maintenance and updates. We will go into detail of each of these items in the next few slides. So, transparency, accountability. sbom provides transparency in the software supply chain, making it easier to track and verify the origin and integrity of each component. This is crucial in identifying the source of vulnerabilities and ensuring accountability. Vulnerability management: with an sbom, organization can quickly identify and address vulnerabilities. If a particular component is found to have a security flaw, the sbom allows for rapid identification and patching, minimizing potential risks. Compliance and regulations: various regulatory frameworks and industry standards now require the use of sboms to ensure software security and integrity. Adhering to these requirements helps organizations avoid legal and financial penalties. Efficient updates and maintenance: by maintaining an sbom, organization can streamline the process of updating and maintaining the software. Knowing the exact components and their versions helps in planning and executing updates without unintended disruptions. Creating and managing an sbom involves identifying and documenting all components within a software application. Various tools and frameworks can automate this process, make it more efficient and less error-prone. Additionally, managing sbom involves regular updates and reviews to ensure that the inventory remains accurate and relevant as the software evolves. sbom standards: SPDX, Software Package Data Exchange, Cyclone-TX, and OWASP Dependency Track. We will go into each of these standards in detail in the next slides. SPDX, comprehensive standard, actually is a widely adopted standard from sboms that provides a comprehensive and detailed formats for documenting software components, licenses, and relationships. Licensing information emphasizes the documentation for licensing terms and conditions, helping organizations manage compliance with open source and proprietary licenses. Interoperability: designed to interoperate with various tools and platforms, facilitating the exchange of sbom data across different stages of software supply chain. Now we look at the Cyclone-TX standard, focused on security. It's a lightweight sbom standard specifically designed for cybersecurity, emphasizing the identification and vulnerabilities and the management of security risks. Extensible formats: offers extensible flexible format that can be easily integrated into existing security and development workflows, supporting a wide range of use cases. Broad ecosystem support by numerous tools and platforms across various programming languages and ecosystems, make it a versatile choice for many organizations. The last one, OWASP Dependency Track, is also security centric. A security focused platform that leverages sboms to identify and manages the risk associated with software dependencies and vulnerabilities. Continuous monitoring enables continuous monitoring and analysis of dependencies throughout the software lifecycle, ensuring that new vulnerabilities are quickly identified and addressed. Integration capabilities: integrates seamlessly with development, build, and deployment pipelines, automating the generation management of SBOMs within CI/CD environments. These are some of the tools that helps creating SBOMs: Swift, Cyclone DX toolset, SPTX tools, OWASP, dependency check, BlackTech by Synopsys, FOSSA, SNCC, JFrog X-ray, GitHub dependency graph, and white source or MENT. In this presentation, I will not go through details of any of these tools, but we can look at the tools in detail in some of the upcoming videos. Now we'll talk about the integration of SBOM in CI/CD pipelines. So automated security benefits of integrating SBOMs in CI/CD. One is automated security, automatically generate SBOMs during build process to identify and address vulnerabilities early in the process. Compliance, ensure compliance with the regulatory standards and industry's best practice through automated documentation. Transparency, maintaining an up-to-date inventory of all software components enhance transparency and traceability of the product. So we'll discuss an example workflow. The build phase, code is checked into a version control system, example Git. CI/CD pipeline triggers the build process. During the build, SBOM is generated using a tool like Swift. The SBOM is stored in an artifact repository. Then the testing and scanning phase, the SBOM is scanned for vulnerability using tools like OWASP, dependency check, or SNCC. If vulnerabilities are found, the build fails and developers are notified. Then the deployment phase, if the build process the security checks. In the testing and integration phase, it proceeds to deployment stage. The SBOM is included within the deployment artifacts for traceability. Post-deployment, the continuous monitoring of SBOM ensures that any newly discovered vulnerabilities are addressed promptly. Case studies. I haven't gone to detail this thing. They will look at this at another time. So some of the challenges and considerations about SBOMs: keeping the SBOMs up to date, managing and large complex projects, interoperability between SBOM standards. These points I will look into upcoming videos. In conclusion, in the era where software supply chain security is critical, SBOM provides a structured approach to understanding and managing software components. They enhance transparency, improve security, ensure compliance, and facilitate efficient maintenance. As the adoption of SBOMs continues to grow, they will play an increasingly vital role in securing our digital infrastructure. Thanks for watching.